assumed that one has specified the total action of the whole. On the other hand, in gravitative biology, reductionism and superposition are only pale shadows of the total biological truth. Now, one approaches a completely holographic situation. The part exchanges with and conditions the whole,
Yes.
and the whole exchanges with and conditions the part.
Hmm.
So, yeah, I like that he's on board with a holographic universe.
Yeah, that's
And
beautiful, and that falls directly in line with my synthesis to your argument. Like the world is a tiered system of these. And maybe my tiers aren't right, but this is how these parts become wholes, and the categories which I think form the basis for how these underlying structures become more complex things or syntheses as they go up the tiers. And I like it's almost like if you were to imagine like two photons coming into confinement, if that theory is true, right? That would mean that like what else could it be? If that theory is true, then all fundamental particles or relative, what I call them relative particles, so like all the fermions, all the other bosons, all the particles which we measure in laboratories are all the results of photons interacting in various ways. And this would mean that those particles, when they become like atoms, so like you take hadrons and electrons, they come together to form atoms. Like what else is there? Like what else is the atom made out of? It's made out of protons, neutrons, and electrons. So hadrons and electrons. And then you get atoms, and they come together to form molecules. Like those are, you know what I mean? Like as you build these up, it's a physical process which you can almost say it can't really be argued against because it's not these metaphysical properties like environment or culture or these other things that other people are using for a tiered process, and but they're actual physical things that are happening to build these syntheses. So in this what you're just reading off, it sounds exactly like that. It's like these parts are coming together to form the wholes, but also the wholes like influence the parts, and that makes sense. And it makes so much sense because like we can like rip our arm off if we wanted to, right? Like we can actually affect our parts. But then you could say, well, that's other parts of our parts affecting the parts. But then it's like, well, we don't think in our minds in parts. Like there's parts that assemble into the whole, but when your mind is acting as a whole, you're connected and we call it like what is it? Not Zen, but when you're in this not zone, when you're in flow, right?
yeah.
When all your facilities are working together in unison to accomplish a task, it's like everything is in harmony, and that's I mean that's how I feel when I do in physics now. But like I feel like it's like I'm getting closer to articulating these crazy understanding of what we're talking about. But like it sounds like a lot of people are on the same track, and you're that's what you're basically explaining to me, right? Like some people like they agree with you because you were arguing the holographic uh, singular photon theory, right?
Yeah.
So yeah, and I was giving that a lot of thought, but the problem, like I understand that it's possible because there photons have arbitrary amplitude, so you can have any amount of photons on top of each other. And I've tried to like figure out a way to create a what's it called, a constant for amplitude for photons. And the only thing I could think of is that you would have to use Planck length, so we'd have to have access to Planck length. So I don't think it's possible for us to measure the amplitude of photons because like if you imagine like you have a photon right next to a photon and they're in phase, like this would be like a laser, right? You can't really see the difference between these two photons. It is basically identical. So that like we can't ever measure that, and that sucks because it would really help us in order to understand whether or not these things are the same or not. You know what I mean? So like if these two photons are separate and they're always separate from each other, or if they actually become a whole, or if they started as a whole and divided into parts, and this is where things get like really confusing. But I, it's hard. This is a very hard problem. But I don't think we'll ever have access to the theory you propose. So it's one of those things that it's an axiom, right? Like I think it's a starting place, and I think it's a fine starting place. But it's just like hard to argue because there are like if I have a photon here and it's interacting with something else and a photon over here, your argument would be that these are just two different manifestations of this holographic reality, right?
Sure.
Okay. So then the holographic reality can interact with itself in order to manifest each particle or each thing we see in any given space.
Right.
Okay. So would that mean that every single photon is responsible for space, time, and energy?
It seems that way.
Okay. Yeah, and I don't have any argument against that. I actually agree that photons are responsible for relative reality. But once you get past that, once you get under the Planck length, that's where photons don't exist anymore. And if you assume that the universe is fundamentally continuous or discrete, if you think that it starts with photons, you have to argue that the universe is discrete if you accept that it has some sort of size. But if you think photons are arbitrarily sized, then the universe could actually be like what actually gives the universe size at all. If everything is photons, like imagine the universe is one big photon, why does it have any size at all? And that would be probably the biggest argument against it that I can think of off the top of my head, at least.
That's pretty, yeah, that's pretty insane, isn't it? And also crazy to think about like how space, I mean, size is relative, right? Like it
Yep.
depends on how how big are you in comparison to what you're observing. That's the ratio between the sizes that
Yep.
makes size significant, or magnitude
And
significant.
the speed that you're going at will affect the size of something. Pretty much,
Right.
yeah. Yeah.
Well, that's a revolutionary thought right there. Um,
Well, no, that's Einstein's relativity. I don't know if you were joking, but that's
um,
special
oh
relativity.
yeah, but like to grasp it like intuitively, like the faster you go, the more things seem to like shrink into your field of view. Like that's
Yep.
kind of like whoa.
Yeah,
Um,
it's jarring a little bit.
because once you hit the speed of light, like the entire universe just collapses into a singularity, doesn't it?
Hmm.
Um, yeah. Um,
You don't mind if I record us, right?
oh, this is fine. That's fine. Yeah, go for
Okay.
it. That's awesome. Um, okay. Can I finish reading this part here?
Yeah, let's go through
So
it together.
So it says, in gravitobiology, fundamental changes are made to two untouchable primary sciences, general relativity and quantum mechanics.
Hmm.
In so doing, one unites and extends both of them into a common unified approach and drastically enriches the present conception of the physical exchanges in, of, between, among, and within physical systems. The foundations, the foundation changes to general relativity the foundation's changes to general relativity allows the incorporation of a hidden variable theory, the Whittaker internalized electromagnetic energy structure of the potential, without violation of Bell's theorem. First, one must change general relativity. One must unite electromagnetism and gravity on the most fundamental level possible, that of the quantum particles and of the fields. The clue to the procedure is the fact that, in quantum field theory, the graviton has spin 2 and the photon has spin 1. This strongly suggests that two photons ought to couple together to produce a graviton if the resultants of the electromagnetic and of the E and B fields of the coupled photons are reduced to zero. In fact, such a bound coupled, as in a standing wave photon-antiphoton pair, makes a basic spin 2 graviton. However, in the vacuum, virtual photons are appearing and disappearing all the time, at
Hmm.
incredible rates. Further, from the standpoint of gravitobiology, we state that these virtual photons are also coupling, modulating each other, and decoupling, demodulating all of the time,
Hmm.
again at an incredible rate. The virtual photons are coupling and decoupling, modulating and demodulating with each other at such intense rapidity that to speak of a fixed spin 2 coupling ignores the fact that it is really only an average coupling that stably exists. Any number of photons can simultaneously modulate, and they do, and just as quickly, they decouple. Hence,
Hmm.
the number of instantaneously coupled photons at a point in the vacuum is always dynamically changing over a very great range of values. Further, continual decoupling of these coupled photons also occurs with intense rapidity. The coupled photon ghost form structures in the vacuum are always continually being annihilated as well as created. In his fastest observation, of course, the macroscopic observer detects and observes the sum of a vast number of these virtual photon couplings, decouplings. He will thus detect only the average coupling. Um,
Okay. I kind of see what he's saying here. Like they're coupling, and when we actually perceive a particle, it's the average coupling of all the individual couplings going on underneath. Maybe
yeah,
something like that.
and aren't we talking about like constructive and destructive interference patterns?
Yes, exactly. And I agree with almost all of this. The only thing I would change is that so like we currently as we think of particles, they require a certain threshold in order to for them to gain their identity, so their rest mass. So this is why another reason why I think it has to be two photons, because I just did a video on E equals mc squared. I'm not sure if you saw that, but it basically goes over how when photons, like you can imagine, whatever the mechanism is by which they enter confinement or orbit, or they they enter destructive and constructive interference with each other. Basically, what's happening is that the energy that was in motion through time and space now no longer moves through time and space. So that's what I walked through the process of how you get 2c squared and what it represents, right? Because c squared is the translation factor between E and M. So if c squared is the translation factor, then just understanding what c squared represents allows us to understand the mechanism by which particles gain mass. And that's why it's so confusing why we create this whole nother particle called the Higgs boson in order to understand how particles gain their mass, when in reality, it's just like c squared. What else can translate c squared other than a photon? There is no particle that we know of that goes this speed. There's no thing that goes this speed besides photons. So how is it possible that anything other than photons is responsible for collapsing these things into a stagnant rest energy? So you have these two things going at the speed of light. They have no relative structure yet. So a unified, maybe like your theory, or like the theory you advocate for, is they're holographic aspects of each other. They enter a relational confinement with each other, in which they now give rise to relative space and reality, because now this photon or these confined photons can now establish a relationship with other particles. So at first they had no relationship because nothing was interacting. You can think of it like in the beginning of time. Nothing's interacting besides photons. Photons interact with each other, manifest the first particles, which I think are neutrons, and I think you said you agreed with that at one point.
Hmm.
So
Yeah.
yeah, they interact, they manifest all these neutrons in this way because of a triple confinement variation of what I'm trying to articulate. And they had to have enough energy in order to do so, though, right? So it can't just be these the sum of all the little interactions happening underneath. Maybe it's possible there's something else underneath photons, but it had to be two photons with the energy, because we know that the angular momentum of this system is translated by photons, by individual photons. So photons can only this is what the virtual aspect of those particles represents, because those particles don't actually ever interact with anything. Maybe they're floating underneath or inside of these particles, or on this around the outside, or whatever it is. But in order for these particles to actually interact with something, they have to translate all their symmetries. And this is something else I had to wrap my head around, is like, what are symmetries? Well, photons have angular momentum, which has to be translated. So that's h bar, which is Planck's constant. So that entire thing, whatever it interacts with, has to be transferred, or it'll either scatter, or it'll pass through it, or go away from it. So like that's the particle aspect of a photon. Like that's the mechanism by which it facilitates interaction. So the particle or the thing it interacts with has to be able to receive h bar momentum. So either a negative h bar or positive h bar, depending on its helicity. And I don't know if you know what helicity is, but that's another thing that has to remain symmetrical.
Mm. Can you go over what helicity is?
Yes. So helicity, like imagine you're riding on a photon, like you're bareback in that bitch. It's either going to go over to the right or over to the left. So like if you imagine it doing that spiral, as it's spiraling, you're riding on top of it. it's going to spiral to the left, over the top and around, which would mean it's left-handed, or over the top to the right, which means it's right-handed. So it's relative to its direction of motion. Is it
So are
rotating
we
to the left
talking
or right?
clockwise? Are we talking? Oh, are we talking like counterclockwise, clockwise relative to the
Exactly.
direction of motion?
Yes.
Yeah. Okay, cool. Yeah, like a corkscrew.
Yep.
Um, and like, so when we're talking about like transverse waves, like, is this like a more proper way to think of a transverse wave? Like, um, the sort of corkscrew pattern going on through
Yes.
space?
Yes. And like I can actually show you what I've been working on. So
There. Oh, okay.
this is a funny way to introduce it, but this is my current model
Whoa.
for when photons actually intersect with each other.
Oh my God, thank you.
So
This is
this,
a godsend.
yeah. So this is two photons. So let me go show you if I can figure out how to
Wow.
navigate this. Okay, so these are individual photons right here, or yeah, individual photons. So what this would be, um, there's the magnetic field, right, which is uh, one of these wave functions right here, and then there's the electric field, and the electric field always is 90 degrees in front of, like if you were to imagine that rotation, right, like that's going around. I really wish the zoom on this was easier to use. Like it won't let me zoom in all the way on the particles. But let me get a good angle. Try to get a good angle. Okay, this is a good angle. Okay, so you see how this side's pointing down 180 degrees, right? So if we were to
Yeah.
consider this a circle right here, this would be down at 180, while up is 0 degrees. So
Uh-huh.
if we see that this thing is rotating around, this would be clockwise towards this red line. So this photon's moving towards the red line. It's rotating clockwise relative to its direction of travel, but it's towards us, so it looks opposite to us, right?
Right.
So then you have this electric field, or this is always the electric field. The lead field is always the electric field. So if it was rotating the other way, this one would be the electric field, and this one would be the magnetic field. So if you were to look at the
They
other
switch roles.
particle,
So they switch roles depending on which way it's spinning.
so no, it's not that they switch roles. They always have the same role, but you can almost imagine it like the way I like to think of it is like imagine you're um, imagine you have, let's see, you you see the center section of my picture, my profile picture.
Yes.
So if you just take that squiggly line, right, and you turn it on its side, you can imagine either the front or back is the higher wave and the other one is the lower wave. So that means it's always compromising. It's like a compromise between electrical and magnetic energy because one is pushing up and what the other is pushing down. And this just might be the way it manifests. So one is like a pull and one is like a push. Does that make sense?
Yeah, yeah, that makes sense.
Okay.
Sure.
So the electric field. So which one of these would be the electric field? The one pointed 270 or the
The
one
one.
180?
Well, so it'd be the leading one, right? So it'd probably be that one.
Which one?
The um the
Which way
the
is this screwing relative to the line?
well, let's see. It's spinning like counterclockwise.
Relative to,
Like
yep, relative to its direction of travel, right? So if we were to look right on it,
yeah, so it's going that way, right?
yep. So which
So
one of these would be
I assume I think it's that first one would be the electric field,
which one's the
like
first
the
one?
one in front.
270 or 180?
Um,
So if you were to imagine like a circle from our direction, we're looking at 180 degrees here, 270 degrees here.
yeah, well, maybe 180.
So this one, you're thinking this one is the electric field?
I think so. I'm confused by the
Okay.
rotating.
Yeah. This is the magnetic field. So again, the electric field is the one that's in the lead, and the magnetic field always follows by 90 degrees. So I could
Yeah.
rotate this to where it's 180 degrees and the magnetic field is facing directly away from it, but it wouldn't make any sense with what we observe because the magnetic field is always 90 degrees from the electric field. Or we call them, in physics, they call these B fields and E fields. So the magnetic field is a B field. I don't know why they don't call them M fields, but whatever. So these are two individual photons with opposite helicity. This one is a right-handed helicity. This one is a left-handed helicity. So these are the only two types of photons you can have. Everything else is just arbitrary wavelength, which is over here. So you have this really short wavelength, and this is a really long one. And this wouldn't matter if, I was trying to picture this in my head, like what would this look like traveling through space? Because we know that a photon never actually reaches it doesn't interact with anything until it reaches its final destination. Because like I said, it has to deliver that full angular momentum of h bar. So I was thinking, like, what if these just keep stretching out until they reach their destination and then they push all that information in? And I was thinking, like, does that have to do with the Doppler effect or the inverse wave law or the propagation law, right? And I was like, wait, even though individual photons do not act like waves, even though, as we see many examples, they'll present us with a wave probability matrix. So if we kept shooting individual particles at a wall, what we're really seeing is the chances of it either destructively or constructively interfering along that wall. We're not actually seeing the individual photons, because if we had perfect information, we saw every interaction all the way there, we could actually predict where the photon is and where it's going. But because these things are operating at the Planck length, we only see them when they actually interact with something. So, and this basically cancels all that understanding of like it's an observer effect or the other thing, which is that it reacts retroactively. Is what they tried to do was interact with the particle in midair, like they did this with electrons, because you can't do it with a photon, it's too fast. But they interacted with the electron to measure it mid-flight, and basically what it did was retroactively cause it to act like a particle, because what they thought would happen is in midair it would keep acting like a wave, but interacting with it in the air causes it to maintain its wave-like aspect. But they're like, no, it resolves back into a particle. And what I'm saying is because you just constructively interfered with it. That's what you just did. It wasn't observer, it wasn't magic. It didn't retroactively program itself to collapse. It was your interaction with it that collapsed this function, or this wave, or this particle this wave into a particle. So you engaged in constructive interference by measuring it, because a photon or even an electron will only interact or be able to be measured if you see a change in its interaction. So if you throw a photon at an electron, you could measure the scattering effects or the things that scatter off of it, or you know what I mean? But you won't really know what actually changed or anything that happened to the electron. So anytime you're measuring particles, you're interacting with it, and that's causing a collapse of its wave function through those interactions, through constructive and destructive interference. So yeah, so that's pretty much the majority of what a photon is. So obviously you have h bar, angular momentum, you had helicity, we have wavelength, and then electric field, magnetic field, and that's basically it. So obviously you have amplitude, which is just stacking these things on top of each other, but like we're talking about the actual structure of a single photon. I can't really think of anything off the top of my head I'm missing, but I may be missing something. Regardless, welcome to your class on photons.
Yeah, no,
Like,
this is amazing. I love the models. They look great.
yeah, and I mean, I want to preface by saying, like, I'm not actually, like, I haven't been to school for physics or anything. These are all stuff I've just learned about. Like, obviously, everybody studies, like, some aspects of wave functions and stuff in calculus, but I just want to make sure that you know that, like, I'm speaking from what I believe, not necessarily what is definitely found to be the case.
Me too. I'm doing the same thing. Like I never
Yeah,
went to school for it, but had a fascination with it anyway. So
yeah,
I'm just exploring that fascination. And I do notice that my perceptions of the world do differ from like people who go to school to study physics. So,
definitely. And
um,
it's because they have a lot of their views are rationalized. So they've like,
yeah,
oh, I've been trying to understand spin, and I'm getting ready to make a video on spin, and it is the most complicated, like abstract, um, non-intuitive aspect of physics right now, and I think it's leading us so far astray from the actual things that are going on to where people are like coming up with all these weird theories about manifolds and extra dimensions. And like, dude, there's only three spatial dimensions. Like, I like, tell me the measurement of a fourth spatial dimension. Like, tell me, like, show me where you're measuring that. And I'll, you know, like, they're because they say they're not. They're like, we're not measuring this. It's just an artifact of what we're doing to these particles in order to get what they say. And I'll just give you a sneak peek because the biggest the biggest problem right now in physics is the spin group SU2. So I mean, spin groups are really complex. It's so super annoying, but you can imagine. Let me just go over real quick. So if you have a model of a 3D rotation of a particle or any object, right? What you can imagine is like creating three separate planes for which you can model on those planes every possible rotation angle that object can be at, right?
right,
So you'd have an x plane, a y plane, and a z plane, and on that you would have a coordinate system that's circular in nature, so that you can plot every which way this thing can rotate. And basically, this is a SU1. I think it's a SU1 group. Regardless, it's just like, no, that's the thing that we most people operate in. Like, if you were to take any object on your desk, you rotate it around on itself in any which direction, that is an SU1. So an SU2 is meant to convey that, oh, it's so hard to articulate, but it's basically, okay, so this thing is it has two different physical characteristics. One of them is rotating in isolation, and the other is rotating in its own isolation. So these groups can be self-referential in that it goes in its own direction, or it can be tied directly to the rotation of the object itself. So let's imagine we have a 2-to-1 ratio between these SU2 groups. So this means that I rotate this object 180 degrees, and the other thing only rotates 90 degrees, or 270 degrees. So this would mean it has a relationship where every rotation actually increased by a certain amount or percentage compared to the rotation of the actual object. And what's a good example of this? There's actual physical examples of this happening, right? Like if you rotate like a turbine, or like a good example, gears, right? Gears are ratioed, so any rotation of a gear rotates the smaller gears less, right?
yeah,
So this is a perfect
right,
example of what's actually happening. But they basically don't look at those gears as separate. They just think of them as the same. So this is one entity that which I spin one, and the other is spinning at a higher rate
right.
or at a lower rate. And that's
So if you
exactly what I think is happening, but they've misarticulated it. Go ahead.
Yeah, and if you have like a bigger gear attached to a smaller gear, then is the smaller gear going to spin faster than the rate at which you're spinning the bigger gear around the center?
Exactly. Yep.
Yeah. Yeah, I've seen people make really cool clocks like this.
Yep.
Um,
And I think
okay, so
that's
then,
interesting that we just talked about, because that's probably the best way to summarize what an SU2 group is it's like a gear ratio. Um, Go ahead. Did you have another question before I continue?
um, well, you should continue.
Okay.
Yeah.
Okay. So let's go on to what the SU1 group of a photon is. So I think they also use SO3, but like, dude, there's like, I don't even. I'm still wrapping my head around all of the groups and how they actually interact with physical things. But let's just go over the SU1, which we were going over first, which is a regular translation of a spin one particle. So this is something that translates directly on its axis. So right, Okay, so imagine, so here's the photons we have again, right? And we have its wavelength, so we measure this wavelength on it. And then obviously we assume that it's continuous forever, but whatever. Excuse me. So that if we rotate, let's say we rotate 180 degrees, basically what happened to the wave function is now it is completely opposite. So it's called out of phase. So this function rotated 180 degrees, which would put it out of phase. Okay, let's rotate it another 180 degrees. So we did a 360-degree rotation, and it returned back to the same exact wave function, right?
Right.
Okay, now let's go to a photon confined particle and see what it is that's happening. So I'm going to first explain it from their perspective, and then what, obviously is going on. So what they think is that it's a Mobius strip. Basically, in order for a particle to rotate back to its original state, it has to rotate 720 degrees, so 360 degrees twice. So a 360-degree rotation gets it to that opposite wave function, which would be out of phase, and another 360 degrees will return it back to its original state. But if you have, okay, so that's their perspective. But if you have two photon confined particles, or sorry, if you have two photons that are confined, if you have their wave function, let's say this is their wave function, right? And they're obviously canceling out their polarity and a lot of other things in terms of their helicity, etc. But if you just rotate this thing 180 degrees, so look at this. This is on the right side, right? The end of the wave is on the right side. And if you rotated it 180 degrees, now it's on the left.
Right.
So this is what they're seeing. So they see this wave function that's going perpendicular. They rotate it, but now, they rotate it 90 degrees, and now they're seeing this opposite wave function. So this is because it's kind of like what you were saying, holographic in a way, because these things do end up being polarized or holographic to where you can only see one or the other. This makes it to where you can only see this wave function, but if you rotate this, so we have this one to the right. These have opposite helicity. There's something not right about what I'm saying. Okay, let's just do it like this. So you rotate it 180 degrees. This thing has its opposite wave function, which would be negative. But that's not quite right either. So, okay, so yeah, what they're seeing is basically that this particle, it rotates, they see another wave function, it rotates again, they see another one. So like it's happening twice as fast. So it would lead to them it looking like it requires twice as many rotations in order to get back to its original state, but really it's only rotating 360 degrees. Does that make sense? I don't know if I did a good job explaining that.
I guess, can you explain it one more time? And
Okay.
also, because my friend Mushu's here. What's up, Mushu?
Yeah, what's up, Mushu? Okay, so you have the wave function here, right? And I'm not sure which one would be visible, but let's just say only one wave function is visible and that they kind of cancel out into each other. So when we rotate that, what we'll see is like a holographic expression of these wave functions as we rotate it. So when we rotate it this way, we're going to see the wave function going across this direction now. And then when we rotate it again, we'll see it go across this direction. So every time we rotate it 90 degrees in space, we're seeing the wave function from a different perspective.
Right.
So what's happening so we know that there's four vectors or four angles in which we can look at a photon. But what's happening when let's assume this is an electron. So what would happen if a photon interacted with this is that it would flip the helicity, or sorry, it would rotate this 180 degrees, because what's going to happen, like a photon rotates 108, sorry, a photon rotates 360 degrees back to its original state due to h bar. So if two photons interacted, then they would return themselves back to that original state. But what's happening here is that it's only giving each one half of that rotation. So like if it had to give its energy to this particle, each one of these photons, or each one of the confined photons, is now getting half of that energy. So it's only going to rotate half as much. So it makes sense that if a photons would rotate 180 degrees, or sorry, 360, then two confined photons would rotate 360. Sorry, gosh, 180 degrees. I'm getting tired. So this is what's actually happening, is it's rotating 180 degrees, which is flipping the wave function out of phase. So if you were to imagine a wave function, I can make it easier if I show you a drawing of a wave function, because like this is like, it's hard to conceptualize when you're seeing a 3D model of it. Let me pull one up. Let's go and just make one easy.
Be based or lose you replaced.
Okay, can you see this?
Yes.
Okay, so let's imagine this is the photon. This is we're just looking at the electric field. And this is its starting place, and then here's its ending place. So it's going, let's say it's going in this direction to the right. So this would be, we could just assume that it's right-handed. It doesn't necessarily matter. But, okay, it's probably not very visible when you do this. So when we translate a photon 180 degrees in space, it returns to its original spot. You see how that works?
Right. This is like analogous, kind of what's going on
Is
in
this
metaphysics.
symmetry?
But this is not out of phase. So what needs to happen? Yes, symmetry is a lot of this. So what needs to happen is the photon actually needs to rotate 180 degrees on its axis that way in order to get the opposite function. So if we made our same, I should have copied it. But you see now they're opposite. So the translation is happening on an axis by which the photon no longer rotates. So it would have to, instead of rotating, let's see. Instead of rotating 100 degrees, 180 degrees, I think this is the first time I actually modeled this, so this is actually important. I guess it could go either way too, so I can put both of these. Oops. Do you guys have any questions or anything? Anything that sounds retarded?
I do have a comment, a question on your model that
Yeah.
I kind of want to express after this, but
Okay.
um,
Okay, so instead of rotating around on its axis, it flips. It's just weird that a rotation in one direction causes it to flip. So rotation, what would this be? Laterally? A lateral rotation. It's almost like, what would it be like? Ah, so it's like if you pulled up, like imagine you're driving in a spacecraft and you pull the lever up, right? You're still going in the same direction. If you keep holding that throttle back or the shift back, right? You're just gonna keep doing a loop, and if you ever let go of it, you're going in the same direction. No, that doesn't make sense. Hold on, let me think about this. As I had it in my mind just now. Okay, so imagine you try to flip and turn around, right? If you pull back the lever and you turn around by pulling back the lever, you're going to be upside down, right? But if you turned around by just turning to the right, you would actually be facing the other way.
Yeah, yeah, yeah.
Okay, can you see it in your head? Like if you're driving a bus and you turn around, you're going the other way, facing up still. Your head is going up towards the ceiling. But if you flip the bus upside down on its back, facing the other way, then you're upside down. So that's the effect that's happening in a spin particle. So no longer is the translation happening by rotating it. Um, it's now doing that rotation in another direction that it couldn't do before, which is to say um, it's rotating back on itself. It's hard to. So it's now rotating on its back rather than turning, or yeah, rather than turning its direction. Dude, this is actually perfect. Oh my gosh, this is like, I didn't even think of this before. This is a perfect way to conceptualize the difference of what manifests as a result of electrons or photons being confined in electrons. It's now able to spin in a direction or rotate in a direction it couldn't before. Because if you're imagining that, like it's like photons are like driving a bus, it can never flip on its back. But when it's in a particle, it can be like a jet fighter where it's able to turn in any direction. It can turn left, right, and back on over itself and still maintain its like its identity. Even though photons can be out of phase as well, but this would be resulting, they're likely the result of us flipping it over on itself. But that's why when you rotate an electron, it results in it getting to a negative phase state. I don't know if there's any of this is making sense to you guys.
It certainly takes, yeah, a lot of spatial reasoning. That's for sure. But yeah, I think I understand. Like for the like in my mind's eye. Yeah.
Okay. So yeah, I mean, it's exactly what's happening to these photons. So when a photon is rotating, what we're doing is we're rotating it on a up. You could say like if you can you think planarly like Cartesian planes. So it'd be rotating on the its x-axis only, not on the y-axis. So spin one particles rotate only on x-axis. Spin
Okay.
two
And spin
and
particle.
rotate on x or y. And this is exactly like my other model. So if I'm gonna save this one real quick, and I'll show you my helicity model. Electron phase geometry. So open. Sure, I'll save it again just in case. Okay, so there's charge. Still working on that. Here, okay, here's helicity. Okay, so these are all the states in which photon confinement can happen. Currently, at least. It's possible that there's more. It's possible to have three photons. I don't know. Okay, so right now I just think of them as two. So, but I have to think about this deeper because the photons can transfer their angular momentum, and if that's possible, then there likely is a mechanism that that particles have as a result of photon confinement that allows them to confine other photons as well. But it would still just be two photons. So the translation would only be in its directionality. So any acceptance of a photon in its identity would be the result of it changing its established identity already. So this would be the rotational energy or rotation of it. So anyways, so if we were to imagine those spinning photons, right? They're going in different directions and also on different planes. So this is all spin 1/2 particles. This is all the stuff that you're made out of. Is these two opposite helicity and opposite plane photons. And what this means is they can rotate any way. So they can rotate on this axis around the outside or up and down on this axis, which makes sense because this means that this photon can rotate and this one can rotate because they can both interact with left or right-handed helicity particles. But a spin 1 particle only has either right-handed helicity or left-handed helicity particles. So any of the bosons, not all the bosons, because some of them are considered to have spin 0. Some are considered to have spin 2, whatever. But either way, I don't think all those particles actually, I don't think they really exist in a way that's actually, they have an identity. It's more like just turbulence for me because they don't actually maintain their identity past like femtoseconds. So like almost every boson besides a photon decays in femtoseconds. Basically, we just see a glimpse of it and it poof disappears. But we're assuming that these particles are responsible for almost every field and every interaction. So like the weak force, strong force, all these forces are governed by these bosons. And I just think it's crazy that we think that these massive particles, they're like 800 mega electron volts, which is like many orders of magnitude larger than the stuff we're made out of, are responsible for every interaction between those tiny little particles with little tiny masses. It's just crazy to think that. It's like saying in order for two humans to interact, there has to be a mountain that exchanges between them. Like that's the level and scale we're talking about here. Like thousands or hundreds of quarks to manifest like one, maybe it's like 2 mega electron volts or so into like 800. So however many that is, 40. Am I right about that? No, it is like 400. Okay, so yeah, I'm probably on the right scale. Hundreds of times bigger. So it's like literally a mountain being responsible for the interactions between people. Like you go to shake someone's hand, and they have to exchange a mountain in order for that exchange to happen. It makes no sense, right? Okay.
Right.
So the same helicity. So this would mean that they can, any rotation or change in their spin would still maintain their rotational, the aspects of the rotation, because it's only spinning in one direction. There's no reason for it to change there's no way for it to change its rotation because it's any effect on its change in rotation would maintain its rotation. It's like you have a bike tire, right? And you're spinning it, or you have, let's say, what is a good way to, no. I have to think of a good analogy for this. I'll think of one eventually. Yeah, I know I'm not going to be able to think it off the top of my head, but basically this is how all the identities would manifest as a result of photons confining in each other. So this would be opposite helicity, but same plane. So they cancel out, creating spin 0, right? This is what you were talking about earlier, Jen. Jen and Nick. I don't know what to call you, Jen or Nick. Or Jen.
You can call me Jen, or you can call me Nick.
Jen sounds
I go by Nico also.
Nico?
So if you want to call me Nico, you can call me Nico. My friends
Okay.
call me Nico.
Okay. So yeah, this would mean that they cancel each other's helicity, right? And then like you were saying earlier with the graviton, this is what they would theorize it to be like. So this is their helicities would cancel out. And this one is a spin 2 particle where their spins add to each other. So this would mean that the particle has twice as much angular momentum necessary in order to change its orientation or whatever, but it would always have the same orientation. or it would only probably be able to flip. I guess I don't even know how it would flip 90 degrees at a time. Um,
So is that
so
to say
yeah,
that it's spinning twice as fast?
um, it's possible. I don't think that so these photons wouldn't necessarily be adding to each other's angular momentum. So they have their each have their own angular momentum, and there's forces that have to be keeping them confined or held together. And I don't quite know how to articulate it yet because I have been going down the lines of vacuum energy being being responsible for it, but it doesn't seem strong enough. So I'm trying to think of how to mess with constants and other things that might result from photons entering confinement at, let's say, Planck length level, and then if they had formed a vacuum in between them and blew up to the say the size of an electron, how much force would be necessary inside of that vacuum to hold these like hold two h bars worth of momentum together. But you could say the system as a whole has two h bars worth of momentum, but it's kind of like saying, excuse me, it's kind of like saying that a an atom has a certain amount of mass, but then you could say the neutrons and the photons and the electrons inside of them each have their own mass, right? It's like the parts make the whole, right? So
Right.
we could define this particle as a whole, but these each one of these photons would have their own separate identities, even though you could say they compromise. So let's say one photon has a slightly higher energy and one has a slightly lower, but if they both came together, it would have enough energy to manifest an electron. This would allow it to, or it would have to allow, photons can only manifest most particles in pairs, so it would have its antiparticle as well, unless it was this is, and I can explain baryon asymmetry as well through this model, and it just aligns with everything that they've been saying. It's just that there's many repeated it went through the cycle many times because there's only like a 2 or a 0.2% chance, but we can get into that after. So like, do you have any other questions on spin identity?
No, but this has actually been very elucidating after to like the yeah, spin identity. The same helicity and opposite helicity. Like, yeah, that's actually very clarifying to understand like what the waves are doing
Yep.
um at the quantum scale. So yeah, yeah, thank you. This is great.
Yeah. And then I guess another thing I have to eventually explain is the way constructive and destructive interference happens. But there's so many videos on that. I don't think I ever need to do that because it's like obviously if you have an opposite wave function, they cancel out. Like, or if you have a, a wave that's propagating in the opposite direction, they're going to cancel out to some degree even. So it's almost like if you have two waves on the ocean and one subtracts the energy from the other, like you have like say one wave going up and one wave going down, or like another way to look is like a rope. If one person flicks the rope in one direction and the other flicks it in the opposite direction on the other side of the rope, they'll cancel out in the middle, right? They'll
Right.
just stop. And that's exactly what's happening. And if you whip it harder on your side and they whip it little less, then the larger wave will absorb that decrease in energy, so destructive interference, and be a smaller wave. But this isn't directly analogous to photons because photons will always maintain their spin angular momentum symmetry. So it's like even if a photon they interact in a way that leads to destructive and constructive interference, they'll always have that spin angular momentum as their identity. So even if they are encased inside of an electron, an atom, whatever they're inside of or interacting with, they'll always have that spin angular momentum. So whenever they leave that particle, they could leave with more energy or less energy, but that spin angular momentum will always be there. If you get one photon in, you'll always get one photon out. Two in, two out. So there's always a symmetry of that angular momentum, but it could leave behind the the relative energy. So like this would be the wavelength, right? How much constricted is that wavelength? And it could leave some of that energy behind, or it could take it some more with it. So that energy can change, but not the spin angular momentum. And if you need help like differentiating the two, I can give you some examples.
Yeah, that'd be great.
Okay. So you can think of like a drill, right? So if you have a hand drill it has torque. So the torque is how hard it's actually pushing that energy, right? And then you can think
Right.
of the wavelength as the frequency at which it's spinning. So the faster it's spinning, the more energy is still contained in it. But it will always like, let's say you held it down, that wrench or that torque wrench will always have the same amount of torque threshold. So let's say you're always holding it at max, but its frequency can change, so it can actually convert more of that energy. I guess it's not a perfect example because you have to think of the torque of the hand drill as being constant, but it can increase in torque based on an increase in amplitude, or and then the frequency could increase at the rate at which it spins. So you can almost think of them as having a fixed amount of amplitude. Maybe that's, I don't know if that's the right way to think of it, but I'm going to look that up real quick. No, it's not. It wouldn't be because spin angular momentum would come in packets. So this would mean that amplitude of a photon is arbitrary, so it can be more or less. And I've actually, I have gone over this before. But there's no direct tie between amplitude and the torque of a spin angular momentum. But the other thing you can think of is how much pressure you're putting on that rate of turn. So let's say you had a hand drill and you were drilling into wood. Let's say you had a constant uh, rate of torque, like you can only apply so much pressure, but you increase, or let's say you lower the distance between. No, that's not a good example either. There's really no perfect analog for a photon because so much of the things that happen at that level are relative to us, right? So we can harvest many photons in order to make almost what appears at our level to be a continuous aspect. So because we're applying these spin angular momentums at our level, it almost looks continuous, which is hard to have a perfect analog. But I think that does some of the justice. It's like it's the torque of the photon, but it's not the rate at which it's spinning. So it's almost like a car. A car has a certain amount of torque. Let's say it's 300 foot-pounds, but it would obviously be different based on the gear ratio. Let's say the photon only has one gear ratio, and it can only provide a certain amount of torque, and it's always that same torque. But the rate at which it's spinning can change. I don't know if that helped you or not. Did that help at all?
Um, a little bit.
Okay.
Right.
So yeah. So I covered a lot. The only, what else did I say I was going to cover? If you wanted to. I said that's fine. That covers pretty much everything you brought up with. Did we cover everything in that? What you sent me? Upshot is an average. The number. Yeah. Okay. The number of average on average, each graviton may appear to microscopic observer to be stabilized at some value between 0 and infinity, including fractional values. Yeah. So, I mean, this may or may not be, like, my articulation may be wrong, but all I know is that there is just space, time, and energy. There is no crazy, like, I don't know,
What if
whatever
those
people are
three are
calling
all
it.
the same thing, or just the same, with just one existence, one being,
Yes, I
and all
agree
the
with
other?
that. I definitely agree with that. But the thing is there are three, but they're each individual. So it's like three separate, but
The,
but
the
but
word
they're interactive.
energy is kind of thrown around quite a lot, but I don't find it very well defined. Isn't energy that energy is a condition in a state that has the property of being able to cause things or cause change. Like, you know, uh, you know, that's energy. Energy is simply, it's not even a thing in it's just it's a, it's a property of the system, you know. Eh, It's not a thing in itself. It's kind of, it has to do with condition, temporal condition. So, you know, energy is always concerned. Energy is not created or, it doesn't even exist in this sense. It's just, I think it has to do with causality. Don't you think? You know, like,
Okay. So let's go back to what you were saying earlier, because where I agree that space, time, and energy are a unity, and that they each individually affect each other. But I do think we can measure them separately. And if I can measure temperature without measuring space or time, then I know it's separate from space or time, even though it may be a manifestation of the interactions between space and time. I can also say the others are manifestations of the other two. So, for example, just from space and time, or sorry, so just from space and energy, I can get the amount of time something takes, and just from its time and energy, I can get the amount of space that it takes. So I can get to the other two just by defining the first two, which is why everybody likes to think, oh, the energy is just the manifestation of space and time. Well, it's not quite right, because I can get to the other thing, or any of the three are manifestations of the other two. So space is the manifestation of time and energy, et cetera, et cetera. And it's one of those things that's a virtuous cycle, because exactly what you were saying earlier, they are a unity at the basis of it.
I guess here's my time, things are changing. Time is change, things moving, you know,
Mm-hmm.
this indescribable, irreducible truth, impermanence. And then space is like a container, like you know, dimension, this kind of set, like this intercon it's a collection of points. A space is all the points, all the positions, all the angles, direction, all that whole collection, interconnected unity. That's space. And then energy is the contents of the space. Like books and tables and chairs are contents within space. But again, they're ultimately all these names. We give names to appearances, to things that appear distinct, but the actual reality is there is no independency or distinct. It's ultimately this indescribable oneness, this
Yeah.
wholeness.
Yep.
Kind of.
I 100% agree. But the thing is, I do believe that the universe is articulatable up to a degree, right? I do believe that there is a fundamental limit to what we can know about reality, but I don't think that we've approached the extremes in every sense of our understanding of reality, or at least
We
relative
can,
reality. Because I agree with you, there's likely this thing outside of relative reality that we call, maybe we can call it absolute reality, where things are perfectly concretized wholes. So, like the idea of God Himself or themselves is like a whole entity by which everything else is derived from. And
but it never becomes anything other than that. It always is that.
yeah, but the problem with that is that's not actually what God wants us to think like. Because if you get too much into this perspective, like you can't see the differentiation between things. For example, imagine a murderer came to your house. Like, I'm sure you would either call the cops or like fight back or something, right?
The
Like,
murder is me. It is me.
yes,
It's
so
only
exactly. And if you saw it as you would do nothing. You would allow it to happen. If the
No,
person
I
wanted,
know it's
no.
me, but I want the me, my ego, whatever, myself, whatever, to remain constant, not to go this
Okay.
terrifying traumatic
So
change. But
why
nonetheless,
wouldn't you want
ultimately,
the
it is
will?
me.
Yeah,
It is
okay.
me.
Oh, so why wouldn't you want the will of the other you to overcome
Because I'm scared
your
of
will?
death, and I'm scared of being reborn in some terrifying.
Okay,
Who
so
knows? Maybe that isn't so horrible, but
but if you were looking at it as a whole, it wouldn't matter either way, because if you viewed his will as equal to your will, then you would say what he wants is just as important as what I want. But you're not saying that, so you
My
do.
will and his
Hold on,
will
let me
are
explain this
one.
because it's going to help. Because if you do think that your will and his will are one, how do you differentiate between whose will is priority?
It would be the I, the me, the
Exactly.
I.
So you have to have a definition of differentiation between you guys in order to even start to establish who takes priority in your view, which is fine. That's how we operate.
Under this, there's only one I. One is just oneness. So
Yes, and
this
again, like you get
problem
back
does
to the
not
same
arise.
problem I just said. So how would you
Well,
distinguish between your will and somebody else's will if all there was one will?
be- because there really is one. It's only an apparent duality, but not really real.
Okay, so again, how like that doesn't answer the question. You're still left with how do you say I'm not going to let this person kill me or I am going to let this person kill me because there is a
Depends
conflict
on
of
my
wills here.
spontaneous feeling, effective feeling. Do I want to, stay alive or not?
Yes, so
That's the only.
you would be prioritizing your life over that person's will. So your will over their will,
Uh,
which would cause you to differentiate, not only differentiate, but prioritize. So now you have a value structure, which is to say that I'm now differentiating between what structure or what I value more and what I value less. And what I value less is your desire to kill me and my desire to live I value more, which is fine. This is a
I think there's
differentiation of
only one
will.
truly legitimate desire, which is to be free from suffering. All other desires are kind of false, illusion. So obviously, I don't want to die
I
because
don't
then
agree with
I'll.
that even. Well, how do you explain people doing hard things? Like, are you saying that that
Because
isn't
it's an
a longer?
investment.
Okay, so
Short
they see it
term
as a longer
pain, but
term
long term
pursuit
pleasure.
of. Okay, so they see it as a longer term pursuit of removing that suffering longer term.
Well, we only strive for two things, two equal opposite. We strive either to remove suffering, pain, or pleasure. And my priority is always prioritizing the removal of suffering is much more important than
Okay,
pleasure.
so let me ask you this: why do people do hard like Goggins? Why does Goggins go out and run like 26 miles a day or more? It's increasing his suffering, and it's not necessarily increasing his. It's
Well,
not actually decreasing any future suffering.
ultimately, because the calculation net hedonic value is more pleasure or removing. It's a metaphysical principle. You can't you can't really impose suffering on your. It's kind of impossible. If you let's say I want to impose suffering on myself, well, you
Mm.
still want it. So you're doing it because of some motivation, some I want it because if I don't do it, I will experience. So, it's just, I don't know.
Yeah, so this is what I like. It's likely that you're reaching an end of what how you can articulate the world this way, and that's exactly what happens when you reach the end of a true dichotomy. You get the other understanding. So the understanding that the world is just the attempt to remove suffering, you can get almost all the way there, but once you reach the end of where suffering is a necessity or almost built into the fabric of reality, you have to accept that some suffering will be not only necessary but inevitable.
You can reduce it, but you can't totally eliminate it, of course.
Yes. Okay, I agree with that. But
Why does suffering arise? Suffering arises from the inherent impermanence of all of existence. That is inherently. So yes, suffering is intrinsic to
yes.
existence.
But we could also say that suffering is good. And depending on how you
Isn't that how we
define
define
suffering,
suffering as something that's bad? Suffering is something that
yes.
which is bad.
Yes, but then if you reduce it to that, then you would have to say, you like go ahead define suffering as only a way. that it can be bad. Because if you're defining it as bad, then it's just everything that is bad is
It's something
suffering.
that feels bad. It's a feeling.
Okay. And do people suffer regardless of whether or not they feel something?
There's no feeling. There's no suffering. Is a
Okay. So if
well,
somebody
no feeling.
can't. Okay. So it's directly tied to somebody's ability to cognitively be aware of their suffering.
Not cognitive. It's called affect. It's a distinct, you know, emotion,
Mm-hmm.
or
A very strongly
in
felt
psychology, it's
emotion.
called affect. It's part of a continuum of pain and pleasure, suffering, unhappiness. This sort of, it's called affect or feeling. It's just this
I know what affect is. Yeah.
thing that affect is the, you know, hedonic tone, the degree of pain, pleasure, or indifference. The, what we would intuitively call feeling, how you feel about something. Like I like this, I don't like this, this is good, this is that kind of.
Okay. And you would consider anything you would put into either the pain or bad category as suffering.
Yes, they're the same thing.
Okay.
So I don't existing in such a state is intrinsically motivates me. I don't even have a choice in it to get rid of it. It's pain,
Yeah.
discomfort. So it's it it's I can't I can't put it in words. I can't tell a robot what is pain like. A robot doesn't have any feelings as such. It's just this indescribable agony that you have to get rid of. So
I just thought of what I was going to say. Okay, so why is it that in today's society where there's the least war, least disease, least conflict, least death for people who are, you know, whatever age they
there's a
are?
lot of income
Hold on,
inequality, a lot of
hold
material
on, hold on,
deprivation.
hold on. Let me fully articulate my argument.
Okay.
So in a world where we have the least suffering relative to throughout all of history, we have the highest rates of mental illness. If suffering is good,
Your
why are we having more mental illness rather than less?
your audio cut out. Right, your audio cut out.
Okay, so you can hear me now?
Yeah.
Okay, so if we have less overall suffering, which you might agree with or we disagree with, we can go over that in a second. But if we have overall less suffering on average for most people, why is it that our mental illness is higher than ever throughout history and
We,
people's anxiety, etc.?
in some, I'm not so sure about that, whether the average typical person really does experience less suffering. I mean, people experience suffering for all kinds of reasons, but it comes down to some pretty basic underlying causes. So, we have certain needs that have to be met, certain conditions that if they're not met, we're just going to suffer. So, we need food, clothing, shelter, maybe, those kinds of. So,
So are there
yeah,
more homeless
many
people, more
cases
poor
conditions
people?
have improved, but in many other cases they've gotten worse. Like in social cohesion, community, you know,
Okay.
having friendships, they've gotten much worse in many. So why are people in pain? Why mental illness? I think it's due to the sort of disorder, social disintegration of social life caused by capitalism, this kind of decline in community interaction, or just people's needs not being met. I think people are very lonely, are very, very fragmented. I think the consumerism that we have, the materialism, people's spiritual life needs not being properly met. If those things are not met, those human people's needs are not being met. So why are people? Because they have unmet needs, and
Okay. And you're
so
saying
I
that
think
you would qualify unmet needs also as suffering?
yes,
Okay.
like,
I just want to be clear.
well, if you have unmet needs, you're going to feel bad. It's directly going to cause that.
Yeah. But then, obviously you have to define what a need is because obviously you define some of the basic needs. But
Like,
we would also start to add many more complex layers on there, which would
The
say
causes and
it's
conditions necessary for human flourishing, human health.
okay. Yes, but like let's get rid of. I don't think that all of the basic needs are a factor because almost no one in America or no one in these first world countries is going hungry or going without housing. Most people, if they need shelter, they need food, they need a
Yeah, their
bath.
physical needs are met, their
Okay,
emotional
that's
needs are
fine.
not
That's
met
fine.
at all.
This is where we have to define what the needs are that you're saying are missing. Then
Develop psychological needs, developmental needs. I mean, the way we're raising children, I think, is very dysfunctional. I think if you think about it, we're raising children in this extremely materialistic, capitalistic way in these cities, labor camps, gray built. It's like life in general is. I think there's a since World War II, World War I, there's really been a substantial, not universally, but a general trend of spiritual, artistic, moral decline. People are, more hedonism or consumerism or
I agree.
like if you look at like American suburbs, for example, these that were built after World War II, that is not an environment that is uh, hospitable for human flourishing, especially for a child. Like that, the conditions that we are in are not allowing for proper human flourishing. There, we're failing to properly thrive. I think I find it's very complicated, but
Okay, I understand most of what you're saying, and I agree with most of it. The problem is what are the necessary sacrifices we have to make in order to go from the state of suffering or more suffering to a state of less suffering?
I
And we could
think
okay, go ahead.
of all the
Because
things we could do, the most important thing is more art, more connection, less of this ridiculous ego, self-cherishing, this, Mr. Beast, YouTube slop. Mr. Beast is everything wrong with the modern world, or, this consumerism, this obvious void that is being felt by people that people are trying to fill from the outside, this spiritual void. And I think of it's complicated. There's not one solution, but one of the most powerful antidotes, cures to it, I think, is art and sort of communitarian participation, citizenship. And people are very disconnected. That used to be more of a thing, and like 50 years ago, 100 years ago, it was that was a lot stronger. The social cohesion, communitarian collective identity was much stronger. People actually could, connect with each other. Americans now hate each other. There's a very big decline in the collective identity. So, that fragments society. So, what can we, you know, I guess what can people do today? Maybe I think YouTube has also declined in the last few years, but yeah, maybe go on the internet, make some wholesome, friendly, warm, you know, good art, good content, something that really brings people together. Isn't the most deepest feeling need we all have is like need for connection, need for seeing other people, this kind of thing. I think you know that's what people are missing more than ever, more than anything else. So, uh,
okay,
so
yeah,
more.
I would agree with most of that, and I think that a lot of that needs to change. And the so the problem is that this is the differentiation because we could say that is it the excess of positive things that's leading to an increase in suffering, so we need to remove some of these positive things or at least reduce them in order to alleviate some of this suffering, or change the scope and scale of what we think that these positive things are. So like we're too like let me explain fully. So we're too oriented towards these physical materialistic aspects and not oriented enough towards our relationships with other people because those are the
I
primary
also
thing.
think
Okay, go ahead.
we're looking for material things to fail that to as a substitute for what we're missing.
I could agree with that too.
Material consumption has become a substitute for human connection. People are this staggers me. This absolutely blows my mind how dysfunctional it is, how sick it is. But people,
Yeah.
I think the most important need human beings have of it more than anything else is the need for attachment and the need to, friendship, need to connect to other people. That that literally releases endorphins. The feel causes a feeling of love. It
Yeah.
directly reduces suffering and stress and so on. So when you don't